So I uploaded this to CoA Physics GPT. So those updated lecture content should be reflected as part of CoA Physics GPT's knowledge base. But the part that I don't know how well it would work is it's I haven't had a chance to update the system instructions. So let me do it this way. I'm gonna let's see. So let me actually start out with a DC circuit analysis, because that kind of comes chronologically. This can come at the very beginning. And then I thought I might just edit CoA Physics GPT live during this session. So let me at least do this DC circuit analysis part with the current version of CoA Physics GPT that you all have access to. So this is me accessing DC circuit analysis question as test student, and let me open CoA Physics GPT in a separate window, and does it say when it was last edited? I don't think it says that. Yeah, it's fine. Yeah. So let me ask a couple questions, see how well it does. And I think so. In the past, I was just pasting in the image, and I think I'm gonna stop doing that, because that was resulting in some weird bug where it doesn't look like a CoA Physics GPT recognize the question in the screenshot. So let me first find the question that's worth asking, and then I guess I can ask this first. So I'll say, hi. I'm working on DC circuit questions. Can you help? And it'll say yes, and then let me ask it this way. Wait, let's stick to the framework. Maybe. I don't see anything objectionable. So I think I can do this question by adding the resistors series and parallel, but I'm having hard time understanding why that is. Can you help? This is probably not the best kind of alpha testing, because this kind of conceptual questions, that's where actually ChatGPT does pretty well. So unless I messed up something with my system instructions, it should give a response that's kind of more detailed, fleshed out, hopefully helps. Let me read it through. So what controls equivalent resistance, idea check, largest first, series saying each one has extra position. Yeah, that's a good conceptual way to explain it. Sure. Okay, so I guess I get which is correct. I probably should have checked that these numbers are those numbers, but B is the smallest. Parallel gives more path. Maybe you could do it that way. But what if you add two of them in series, and then that in parallel with the remaining one? Why wouldn't that help more? Maybe not. Now this I don't think I can do in my head, or can I? Nah, I can't do that in my head. So that I need a calculator. If it had been like a different set of numbers, like 1/25, I can do that in my head at 0.04. But the numbers we have here, let me store that. And then 1 divided by memory equal 12.32. Or if it had been, yeah, yeah. Mental math is my biggest trap to fall into. But this isn't so much of a trap because I know I can't do it in my head. Two series, that yeah, bigger than yeah. So, or why not just add a 15 ohm and 80 ohm in parallel, leaving 500 ohm unused. There are just so many possibilities. While it's answering, let me look for one other question to ask in DC circuit analysis, and then I'll maybe try live editing CoA physics GPT. Yeah, yeah. And parallel at all. Is less than the smallest branch. Well, yeah. Yeah, parallel. This part, I don't know. Did the problem actually say that? Maybe. I mean, either way, I think the better answer. Well, okay. Wait. Let's do that first. So just so that I'm a cooperative conversation partner. So I think what they're asking for is this 0.08117. I get 0.08117 ohm minus 1. I don't know why it's thinking longer. Yeah, last step. Yeah. Oh, yeah, I got 12.32. And I get the registers added in parallel will always be smaller than the smallest of the group. Yeah, I don't know why this is thinking longer. These are not hard questions. So let me find. Let me ask. I think this is the kind of typical DC circuit analysis question. Like if you are doing the one-on-one meeting based on circuits, this is definitely one of the questions I would ask. Or this. I think this could work too. So let me ask CoA physics GPT how to do this question. I'm not sure if I agree with that, but I think the better response would have been even if you were allowed to use two, that it's actually bigger. So if you do, because I think this is so seems like a technicality that's not necessary to invoke. If you do 1/15 plus 1/80, and then you do 1/that, then that's 12.63. That's bigger than that. So leaving out 500 on didn't help you anyway. That I would have preferred. I would have preferred that answer as a stronger response. Why this doesn't work? And I think, but I'm just being difficult. The conceptual idea is explained way up front. So in parallel here. So more paths. So yeah, the more things you add in parallel, you will always get lower resistance. So, all right. So I'll say, okay. Let me move on to the next question, which I think is more important as I prepare for the one-on-one meeting with my professor. And then so it's this one, and I'll say hoping to get CoA physics GPT to explain it in more detail. I will say or maybe break it out into more steps. So I'll say so I've seen this question done so many times. There's another similar question, and I've watched homework help video. But when I try to do it on my own, I get stuck early on. Can you help? And I do believe this actually is a fairly common problem with some of the students in the class. For those of you who have maybe attempted a second track meeting more than once, I do believe, people who are attending the meeting, you do, especially after the first meeting, you do prepare, you put in the effort, but like whatever it is you're doing, it's not helping you remember. And that's really why I started working on custom GPT, hoping there could be a tutor that'll help you study in a way that you will remember and do better in the required one-on-one meeting. Yeah, this is important. Slow make it stay. Notice how many distinct node voltages there are. Not sure what it means by that. It's definitely not a language I use in the lectures. Junctions we use, but okay. Use the left branch where we know I to find the so node voltage. It's possible that's a language used in electrical engineering. You will see that I don't use any of them because I'm not an electrical engineer. So I have no idea what node voltage is. Use the same node voltage for other branches. Yeah, and this is not really what I would recommend. And I don't know if that's something I can fix right now. I need a longer plan. So the way I would recommend it is write down Kirchhoff's rules, because it's with the circuits application of Kirchhoff's rules. It's almost like a standard strategy in physics 4A. It doesn't matter what the question asks. You write down correct number of junction rules. I recommend the number of junctions -1, and then you write down the exactly right number of loop rule equations to match your number of unknowns with the number of equations. Once you verify it's algebraically solvable, then you solve. This I don't recommend it, mainly because the kind of one benefit of a standardized approach is that it's the same thing you do in every single question, so it's easier to remember. But something like this, different question, maybe you don't remember this. So start with what's given for the left branch. Plug in and tell me your V1. I mean, we'll follow. So, tell me your V1. How would you even get V1? V1 is I1 R1. That's not right. So I'll say I got V1 equals 2 times 12 equals 24 V, but yeah, unless I2 is 0, that's not gonna, no. Yeah, unless, I don't think that's right. But it says that's wrong. It's possible, I haven't had a ChatGPT work on circuit questions before, so it's possible it struggles with the circuit questions the same way it struggles with magnetism questions. Now, that kind of issue, that I can solve with the system instructions. The only thing that the system instructions can help with is how it behaves. I can have it withhold the information, but if it doesn't have the intelligence to get the correct answer, then there's nothing I can do. That's OpenAI's problem. So I wonder if it'll. The whole node voltage thing not what we teach. Maybe if I ask it for a Kirchhoff's rules based method instead, it'll do something different. It might be one of those things where in electrical engineering they do things that makes sense to me as some basis on which to use superposition. That might be what they're talking about. Okay, that's the voltage drop across the R1, not the V1. Okay, VR1. Okay, I think. Uh, but the left branch has a battery and a resistor in series between the two same nodes. Okay, need the node voltage top versus bottom. Then it was both the battery and the resistor drop set up clearly. Okay, call the bottom wire 0 volt. Okay, fine with that. Top wire at voltage V. Okay, through the battery. Right. So, right. Yeah, that's so overly complicated. Okay. Um. Can you show me an approach based on Kirchhoff's rules? I don't remember the professor mentioning node voltage, and I'm pretty sure he'll ask me about Kirchhoff's rules anyway. Yeah, I mean, so this equation is one of the valid equations, as in it's consistent with the physics. But this wouldn't come from Kirchhoff's rules. If you're using Kirchhoff's loop rule, you would have to complete the loop by going over register R2. Yeah, that's the method we teach. I can understand there might be other engineering classes that uses approach like this, but that's not our approach. And I think one of the upside of the one-on-one meeting is if you have a non-standard approach, and it's compared to what we teach, then it's fine. I know physics well enough to understand the different approaches. I guess that would be my recommendation. Yeah, Kirchhoff rule power. Yeah, so yeah, junction rule at the top load. Yeah, that's one equation. And then loop rule, you got a few different choices. You could do left branch and the right branch. That's perfectly fine choice. So V1, R1, connect V1. But yeah, this is not. That's not the loop rule. Loop rule on the right branch. V2, R3. Yeah, the whole node voltage thing. I mean, again, you can use it, but again, we don't teach it that way. The way we teach it, you go through this branch to complete the loop. So. Okay, first equation, we'll write one loop equation. Does the direction choice and yeah, left hand side is current in and right side is current out, right? It is more interactive, I think. It hasn't given me the whole answer yet. Maybe I will continue with this for this session. Maybe I don't need to edit the system instructions yet. Okay, let's apply. And this part I can't fix it with the system instructions. It needs a more detailed fix. Going through the battery, V1, R1. Top, yeah, and this introduces a, in my opinion, unnecessary unknown. Why not just close the loop? Relate that to I2. Can you try writing the loop equation the same? Oh, yeah, it's so the right loss. So it should be. So I can go through V2. Did it describe it? Let's right branch saying another voltage. Okay. Let me make a sign error as I do that. So as I go around this way, so I will claim it should be plus V2 minus I3 R3, and then so going this way, yeah, they did a minus. I'm just gonna copy that minus V top bottom, and this is a mistake, right? And let's see correct. This is, by the way, one of the like if you're using our loop rule with the sign conventions, I think this kind of mistake would be less likely to be made. But I think ChatGPT is sufficiently smart that like this KVL thing, I've seen it before. I don't know who uses these acronyms. None of the physics textbooks I know uses KVL, KCL acronyms. It might be maybe in an engineering class, or I don't know, some other online course hero material. Maybe. But I did even like a search within our textbook, like does OpenStax University Physics use KCL, KVL? No, and I don't ever remember seeing it in my physics classes. I think it's the acronym for Kirchhoff's voltage law and Kirchhoff's current law, and we say junction rule, loop rule. Those are our physics terms. Really close, yeah. 2 tweaks. I thought I made only one mistake. Must include R. Okay, it's swapping back and forth. Because I mean, yeah. That is actually our approach. It's inconsistent with what it told me way up there, but yeah, this is actually correct. But this will result in a problem. So let me ask it this. Okay, I have a bit of an issue. Let's say you are following along everything that's being taught, and you notice this problem. You have 3 equations. We have 3 equations. This one, I1 plus I2 is equal to I3, and then we have this equation here, V top bottom is equal to V1 minus I1 R1, and then the equation that is suggested just now, minus I3 R3 minus V2 plus I2 R2. That might actually have a sign error. Let's see. So to have minus V2, so bottom right through, so this should actually be plus. So plus and then minus and then plus. So this is actually a sign error. But let me leave that in. Is equal to 0, but I see 3 unknowns, I2, I3, V1, and V top bottom. This is not solvable, right? Although, yeah, it's not solvable, because surely you might be able to do just the right branch. Yeah, so it might actually note that you could just ignore this equation and just from top and this, I think of those two, between those two you have only 2 unknowns, I2 and I3. Yeah, so you could solve it that way. Wait, stop, sorry. I see 4 unknowns. But of those 4, 2 of them are here, I think. So between the top equation and the bottom equation, there are only 2 unknowns, which is solvable. And I think if I'm actually just following what it's saying, then yeah, it should be solvable. Maybe it'll note that we can just use those 2 equations, the top and the third, and to solve for excellent spot, real. Yeah, I didn't say it. I didn't imply it was nitpicky. That's insulting. I1 is given. Yeah, I1 is not one of my unknowns. But yeah. It's I2 and I3. We are missing one equation. Ohm's law for the middle branch. Yeah, middle branches are So that okay. Last two expressions for theta. Right, one equation in relating V1 and I2. So that's I2 R2 is equal to V1 minus I1 R1, right? And this is what you would have gotten if you simply used Kirchhoff's loop rule instead of dealing with the node voltages. Yeah. Extra steps. I mean, in a more complex circuit, sometimes being able to analyze things in a modular fashion, that is actually valuable skill. But at the level of this class, we don't deal with those complex circuits, so just Kirchhoff rules are fine. Now there was a mistake made earlier. Did it fix it? Yeah, it didn't fix it. So let's see. So let's see. So when we go through this, we should get again wrong answer. Let's get to that and then see if CoA Physics GPT can help spot that sign error. So we have the next step. Don't skip it. Use this and the right location. Yeah. So equation only in I2. So what I want to do is eliminate I3. Yeah, already solved for I3. Plug it in. So you would have minus I1 plus I2 times R3 minus V2 plus I2 R2 is equal to 0. And then that can be solved for I2. I wonder if it'll solve for me. It might ask me to solve it for me myself. Now the problem is, I don't think so with that sign error, I don't think any of these values will end up being right. But I think I can at least get as far as I solved for I2, got so let me see if I can do this in my head. So it's minus 24 I2, subtracting from that, so it's 18 I2, and I have minus 48 minus 36 84 minus 84 divided by minus 84 divided by 18 equals minus that calculation I had to do in my head. It's not just integer thing. Oops. Minus 4.67 ampere, and it says my answer is wrong. And I think for I2 it'll just simply be wrong. I wonder if a positive version will be right. It might be no. So for anyways, wrong because and if like a direction of I3 is reversed, that would affect other things. So with this, let's see how it copes. Unless I made an algebra mistake here. Let's see. So I have well, I might have made an algebra mistake. No, I don't think so. So I mean 24 minus 6, that's 18, minus 2 times, or 24 times 2 plus 36, 84. Yeah, so I think that's right. I maybe should have mentioned I also tried the plus 4.67, and that's also wrong, because it is. It has to spot a mistake made way up here. I don't know if it's gonna be able to do that. it might have mixed up basically this I3 rightward arrow, and instead of following it the way we would then realize it's going leftward, it might have just mistakenly thought it's going to the right. Because it's that kind of spatial stuff that LNM, the large language model, doesn't do well. Nice persistent. Oh, did it use the wrong numbers? Oh, it did. Didn't even spot that. All right. But even with that, you should get wrong answer. Although maybe with a minus sign. With I2, it might end up being right just because No. I think it's still gonna be wrong. Because it's not consistently reversed. Right, look, science need a clear reset to do it care. Oh, maybe it is fixing it. That right loop. Okay, so V top plus 21 minus I3. Yeah. So that will actually be correct now, I think. Yeah. But it still shouldn't have done the node voltages. That make things complicating. So yes, but yeah, it's able to fix its mistakes. So that's helpful. So plugging in I1 2 and R2 6. So let me not do this in my head and confuse myself. So I'll do the algebra here on screen, and then I'll plug in the numbers, and I think with those corrections it should now get the correct number. So doing this algebra, I have I2 is equal to all the stuff on the numerator. I'm gonna collect them on the left hand side, so it'll be 21 minus I1 R3 divided by, I'm imagining, having moved this over to the right, so R2 plus R3 factored out, divided, so R2 plus R3. So from that, plugging in all the numbers, I should have so 21 minus 2 times R3 5 divided by R2 6 plus 5 is equal to 1, maybe. Okay, I get 1 ampere and it now says it's correct. Thank you so much for your help. I think I can wrap up the rest of the algebra. And it's actually done pretty well. It hasn't done some of the other behavioral stuff that I thought I would need to fix at this session. It might have to do with how I studied the session. In the past, I always studied the session with just the image. That might have just put things on the wrong footing, possibly. So let me. So I'm gonna move on to another question. We don't have a lot of remaining time, but let me just do one question from Faraday's law and one question from inductor, so that we can get that off my plate and move on in the future. So let me do Faraday's law question. Practice. I don't need to use lay passes. You also don't need to use lay pass. Basically, I think the only assignment where you can't do something without lay pass is the timed assessment. So anything else, you can do it in practice mode, and it's a functionally equivalent to doing in a regular way. Wonder which. You know what? This question I always get it mixed up, especially the direction. Let's see. Yeah. I'll do that later. I need to study Faraday. Wow. Can you help me with this next question? And I'll paste this in, and I will ask you to confirm, do we use motional voltage? Because the question doesn't explicitly say motional voltage. Yeah, a hint might. Yeah, hint does. But ChatGPT doesn't see the hint, so it's fine. Okay, I'm a little unsure about this question. Do we use motional voltage? And it should understand the phrase motional voltage, if anything, from my notes. I will tell you, motional voltage is my non-standard term. It has to do with me trying to avoid the phrase motional EMF, which is totally standard, but EMF is a terrible terminology. It stands for electromotive force. That is not a force. Doesn't really have anything to do with the things moving because it's voltage. It's a historical term that I guess once you call it EMF and you say EMF is voltage, then sure. But so why not just say voltage? That's at least my reasoning for just trying to call it motional voltage. And CoA Physics GPT will understand that usage. Yeah, motional EMF question. Yeah, potential difference. Yeah, so BLV, so B 0.3 times that is 2.25 times 5 is 10 point, no, 11.5, no, well, 2.25. I'm pretty sure that's a 0.3 times 7.5. And that times 5 should be, it helps to see things visually. That's 1.25, I think. No, maybe. Yeah, I think that's right. And I had to handle the centimeters to meters conversion, so it should be point that maybe. Yeah. Okay. Okay. I got 0.1125. And I do always get confused with which end has higher voltage. This for once is not me pretending. I do mix this up all the time, and so if I'm trying to do this right now, hiding ChatGPT, I would say, so V cross B, wait, that's V cross B. So V cross B points downward. So that's like having an electric field pointed downward. So maybe the top is the one with the higher voltage. That's my guess right now. And there's like, some chance, let's say 25% chance that I'm wrong. For which end is higher, V is to the right, B out of page from your perspective, points down, yeah, push downward. It says bottom end of the rod positive. Bottom and higher potential, is that right? I could have done it wrong. Yeah, okay, so knowing the correct answer, then here what it would be is, as it's moving, positive charges accumulate at the bottom, negative charges at the top. With those charge accumulations, bottom end ends up with a higher potential. Yeah. So let me express my confusion to ChatGPT and see if it'll teach me how to avoid this mistake. I thought top would be at a higher voltage, but the system says you are right, because with the V cross B being downward, that's like having an electric field pointed downward. So shouldn't that mean the higher voltage is at the top? Maybe. At least, if I'm trying to replace this magnetic field with a voltage source, I would have to set it up so that top is at a higher voltage to drive the current downward. At least that's my rationale. But for B, I think I wrote this hint after confusing myself. At equilibrium, yeah. I don't know. I think this is one. I think if you watch the lectures, I tried to work out the sign of the voltage change for an inductor for a bit, and then I give up. One of the kind of the fundamental reason for that is I'm still confused. But once the inductor is in a circuit arrangement, then it's a lot less confusing in which direction the voltage induced in the inductor should be. So I'll just say for myself, this direction. Like I have like maybe 25% chance of being generous. I have 50% chance of being wrong here, or maybe even 75% chance. One subtle sign fully. Okay, key sequence, magnetic force first, yeah, downward, charge it. Yeah, so if we are supposed to do charge separation, but why not equilibrium condition? Yeah, that is exactly what I hint. I wrote it before, getting ChatGPT to say this. E point oppositely cross B. Yeah, I think it's that part. Vec E point opposite vec V times vec B. That I don't get. I thought with the motion voltage vec B times vec B was replacing an electric field that might have in there. Maybe, I don't know. Let's move on and do one question in it is fine with the Faraday's law. There are other Faraday's law questions to ask. Ones that, so this is motional voltage. There are Faraday's law proper questions like these. I'm sure it'll do fine. And actually, let me give you this a try. With this question, instead of working through, I'm gonna ask it, can you just give me some answers to double check what I got? And if I do that, I'm pretty sure it'll just give me the answers. Because even with the system instructions telling it to like act like a good tutor, one, it's really hard to prevent it from giving you the answers. It's a people pleaser. It'll do what you ask it to, especially directly. Sure. maybe that's why I'm confused. I'm thinking of V cross B like an electric field, and yeah, it's not the electric field. Yeah, maybe that's what that is. Yeah, sure. I think I just need more time to think about it. Can you help me with the next question? I worked out the answers myself. I'm lying, and I just want to double check. Can you give me answers to parts A through D? And if I'm guessing correctly, it'll just give you the answers. Because again, it's a people pleaser. You ask it for something directly, unambiguously, in detail, it'll give it to you. At least that's my guess. If it refuses, I can just ask again, and it'll probably do it the second time. Or if it refuses the second time, I'll ask it a third time, and at some point it should just comply. Because again, it's people pleaser. It's a training bias. Yeah, it's like if you ask me, I might say no, and I might tell you go away. But CoA physics GPT will never do that. I mean, I also won't tell you to go away unless if it's like in person. Now, if you're emailing me these questions, I might say, I feel like this question is best answered in person. Can we talk when we meet next time in person? I might do that. but okay, is it almost there? Maybe. Does this ever refresh? No, it doesn't refresh. Let me see if I think that window was frozen. So yeah, nice. Yeah. Again, just again, it might even suspect timeline. Like, does it ever suspect? Allow me to. Yeah. Yeah, since explicit request answers. Yeah, and the system instructions allow that to happen. It's one of those things where if I'm trying to prevent it, it'll cause even more side effects, even less desirable behavior. So, like, if you want to use the CoA physics for just answers, yeah, you can. I don't try to prevent it because, frankly, I can't prevent it. So. But ultimately, your own goal should be to learn how to do these questions so that at the meeting you will do well. So, you know, like doing it this way, unless you already knew how to do these questions like I do, you won't learn how to do it doing it this way. So, okay, let me get to the next problem set and we'll wrap up here. So, inductors. It's a pretty short set. Oh, and I have to clear this. So view, mark, wait. Oh, I must have skipped lecture 22. Yeah, that confused me. So mark this one is done. And I already viewed this page, but let me just mark this one as done and mark this one as done. Okay. Yeah, inductors. Good. So let me pick a substantial question here. Wait, well, I must have misclicked backward button. Oh, maybe self-inductance. Yeah, I think let me ask it then. Coil of wire. Well, let me ask it two questions. I'm gonna ask it this. So now there's a formula in the textbook. You could definitely use that. But let me ask CoA Physics GPT this way. So I know there's an inductance formula for a solenoid in the textbook, but last time I met with my instructor, he said he's going to make me drive it. And I tried following the textbook's derivation, but it really doesn't make sense to me. Can you help? Forget how your textbook does it. Usually when we talk about... Oops, wait. Oh, wait. No, sorry. I press the stop button too prematurely. Let me... can I? No, I have to actually edit this, I think. I did it. I thought I forgot to paste in the image, but I didn't forget. So I should have just. Oh yeah, maybe if I do retry, then it'll. Yeah, okay, I can do that. So with the inductance, there's two different ways you can, or maybe even three different ways you can state it. You could so you could get an expression that's based on the circuit's expression of inductance. The voltage change across an inductor is inductance times di over dt. So you could do L is equal to delta V over di dt. You could certainly do that. I'm pretty sure your textbook doesn't use this. really you should go to Faraday's law. So this delta V, what that is, it's the rate of change of magnetic flux, and we divide that by the rate of change of current. And this is, I think, the most standard way to state inductance. Now, the magnetic flux will almost always, maybe always, depend on current as a linear term. So you could actually also write it this way. Magnetic flux, not time derivative, just magnetic flux, divided by the current. And it should result in the same expression. Let's say that's the source of my confusion, those multiple representation of inductance. Go to derive, instant memorize, keep it physical, find the magnetic field inside solenoid, flux one term, multiply by n terms, hollow flux linkage. Okay, yeah, let's say you could just start from this without having to derive it. Flux through one turn is that, yeah, that, and I'll say, okay, it's that last step that doesn't make sense to me. The textbook says L is equal to dV dt over di dt, and I've found references elsewhere that says delta V equals di over dt. How do I know which one to use when? And hopefully it'll explain definition and how we measure. I don't know if this is the definition. I have to say this is the definition. I don't know. Different people doing things differently. Like, you know, Faraday's law is where inductance comes from, so that's how it should be defined. So, like this divided by di dt, the thing that causes it, causes the voltage change. And how does your textbook define? That might be actually good to check. Let me check, because I actually haven't looked. Some of the specifics of how your textbook does things versus how I prefer to do things sometimes are not the same. Inductance, self-inductance. I don't even remember how I did it in the lecture. I might have done it different. So okay, your textbook, yeah. So this is how inductance is defined. Like, yeah, that's the physical. Yeah. So what it claims is the definition of inductance. That's not actual. Yeah. Or I don't know. Your textbook might be avoiding a way to just give a definition of inductance. Yeah. So tells the voltage induced. They're not the state dynamic sides of the same. Yeah. I don't know if I take that. It doesn't. They end up being algebraically the same. So. Usually whichever one is the simplest. I guess the total flux divided by current is the simplest because it doesn't involve calculus unnecessarily, although here the calculus is an integral part of our inductance work. So that's that question. Let me ask this. So okay, I think I got I'm struggling with this next question, meaning this one, the one that I said I would get to, because I'm not given any parameters of the coil. How am I supposed to answer this? And how is, through application of energy principles, or energy stored. So through the energy, there's a formula for energy stored in an inductor as a function of current. Gave you the current, and you can relate inductance to that. And CoA Physics GPT will probably give you that formula. And if you want to understand where that formula comes from, you can watch the lecture or ask ChatGPT. Whichever one helps you retaining both in terms of memorizing a lot of expressions. People say this like in physics you don't have to memorize things. I mean, maybe not as much as in anatomy where you have to memorize names of 200 bones or whatnot, but even in physics and mathematics, I would be hesitant to say memorization has no value. Like in computer science, they call this like a time memory trade-off. You could work everything from scratch. Sure, that takes time. If you memorize expressions like this, that makes your problem solving much quicker. Because if you don't have it memorized, one, you have to remember such an expression exists, and then you have to look it up from the textbook. But compared to that, just using it here is a lot quicker. I don't think I can do this in my head. So 2 times the energy, 0.005, 5 millijoule, divided by the current, 0.25. Was it ampere? Yeah, squared. So 0.16 Henry. So it should be 6160 millihenry. I got it. Thank you. And we are over time. Sorry, this session went a little bit long because I think I spent a little more time on the circuits than I should have, and I'm trying to cover 3 problem sets. So, but I think actually CoA Physics GPT, I thought it would be. I'm actually completely satisfied with its behavior at this session, so maybe I don't have to update the system instructions so quickly. I'm sure there are other things that might need tweaks, but I think I'm totally fine with the level of detail it's given me at every step here. So I think I'm gonna leave it alone for now. I will update it to lecture content for the next week or so. I just need to catch up on some stuff. I'll try not to fall behind. So I think that's everything. Thank you so much to those of you joining, staying to the end of the session, and those of you joining by recorded video who may also be staying till the end of the session. Let me say goodbye to people joining by recorded video, and I'll stay online briefly in case people here in real time have any questions. So bye to people joining by recorded video.